All right, you guys ready? You ready?
Sir.
All right. Are you ready? Nasbera, are you ready? All right, class.
Yes.
I was hoping for better. Do you know what's really bad? My last class of the day, my 7th hour, they're always on top of things. They really are. They're like, yeah! I'm like, what? They're like, yeah! Just like that. Okay? Because everyone's participating and no one's playing with their cell phone during this time. Because everyone wants to get a good grade and no one would play with their cell phone during my class. So let's say, for instance, I paid attention to my notes. What page in my notebook am I on? 39? Is it? It is 31. So it's almost like I read this. You know when you come in every day? It actually says what pages you're supposed to be on right here. This says 30 and 31. So today's notes are 31. All right. Now let's see. Events involving and conditional probability. And probabilities with independent events. Two events are independent if the occurrence of either of them has no effect on the probability of the other. Now, think of this. I flip a coin. Wait, I think I have a coin. I have one of these giant foreign coins. It's like huge. It's like ridiculous. Huh? It's a green piggy bank. Anyway, so this huge coin right here. I have no clue which one's heads or tails. Anyway, so I flip the coin. Bam! Boom! I think that's a tail. Okay, yeah, it's tails. Okay? So now I'm going to flip the coin again. Because I got tails the first time, doesn't mean I have to get heads the next time? No, right? So what does that make that? That means that that is going to be independent of the next one. Okay? Big Vinny has 19 kids. Okay? Yeah, something like that. So, the first 14 kids were all girls. Man. Big Vinny kept trying for boys. He wants to have a son that could, someone take over the family business of hair care products. Okay? Yes.
You went 14 rounds?
Huh?
You went 14 rounds?
Anyway.
All 19 same girls?
Anyway, so every single time the next kid, he's like, man, this one's got to be a boy. I already had a girl, right? Is that an independent event from the previous one? Yeah, right? Different big mamas? Okay, yeah, different big mamas, okay? So, yeah. If you ever see this guy's face over on, what's it, Tinder, J-Date, okay, Farmers Only. So all those right here, do not, this guy right here, okay? Might as well be Farmers Only because this guy's throwing seeds everywhere. See what I did there? Okay, anyway. So, that is an independent event from the previous one. Just because there's a girl the first time doesn't mean that there's got to be a boy the next time. That's what this is referring to. Independent events. Okay, and the probability with independent events is if A and B are independent events, then it's A and B, which turns into a multiplication. A and B is going to be a multiplication because I am not just having one event, I'm having a second event. So it's kind of like when we were doing this last time, we would select one car. This time, we're selecting a second car. So if you think about this, use your noodle. I take my 52 cards right here, and I am dealing cards. Big Vinny. Bam! He gets that ace on that first card. So, for him to get an ace on that first card, how many aces are there? There's 4 aces, right? There's 4 aces out of 52. Okay? Now, this is an example of a dependent event. I'm going to deal him another card. How many cards are left in the deck?
48.
I gave you an ace the first time. So I deal how many cards? There was 1 card I gave you, right? I gave you 1 card, didn't I? Okay, so how many cards are left if I just dealt him 1 card? 51. So that means that the second card is dependent on the first card. So is it possible to get an ace of diamonds the second time? But what if I gave you an ace of diamonds the first time? It's not possible, right? Because that means that is a dependent event. So you can't get the same card a second time, so that means that is dependent. If it's independent, that means that it has nothing to do with what I got the first time. Make sense? Good. So, right here, when we do this, this is going to be a multiplication all the time. Example 1, independent events on a roulette wheel. A U.S. roulette wheel has 38 numbered slots, 1 through 36, 0 and 00. 18 are black, 18 are red, 2 are green. The ball could land on any slot with equal probability. What is the probability of red occurring 2 consecutive plays? First, what is the chance of me getting a red on the first try? 18 out of? Very good. So it's going to be 18 out of 38. That's an 8 right there. Good. Huh? Yeah, that's where they spin the ball. No, they spin the ball.
Yeah, and like they choose like a number.
Yeah, and it comes up, right?
But it has to be the exact number and color, right?
Depends.
No, you can just call a color.
Okay, so you could bet on a color. You could bet on a group. So you can go corners. But we're not gambling right now. So anyway,
If
so
you do numbers and colors, you get like more money.
the more money would be pick the exact.
Yeah, that's what
But what you could do, which is put your money on a corner. That would be a 4 corner. So if it's one of those, you get 1/4 of the bet. Does that make sense? Okay, so good. So I know that everyone's paying attention because ain't no way in hell anyone pulled out their cell phone and not pay attention. Ain't no way that Michael has his earbuds in during this lesson right now. Bruh, that's you. Yeah. Anyway, all right. So now, the second event. The second event. So right here, can I get red again?
Yeah.
Yes, I can. I can get red again. So is that going to change because I got a red the first time? No. That means it is completely independent. 18 over 38. So let's do the math. What's that reduced? So that is 19. So 9 squared, that's 81 over 19 squared, which is 361. I need you guys actually like double checking this because I suck at math.
you got it.
I did? Oh.
Is that time?
No one else would choose this. Okay, listen, I woke up one morning and I chose violence. They're like, oh, you should be a math teacher.
Is that time?
Huh?
Is that time?
Yes, that's times. It's multiplication.
Yeah, it's like 22%.
Yeah, we'll get to that here in a second, all right?
Is there a reason for multiplying?
Yes, because the formula said to do so. So you'll see a little bit more here in a second, and I'm going to explain why, all right? So Big Vinny, he did the division. He divided it, right? And when you divide it, what does that give you? 2 to what? Like that? Okay. And so that as a percent would be. Okay, so there is a 22.4% chance of getting red and then red. So you could actually bet on that too, that you're going to get red twice in a row. You get better odds on that one. You would make more money if you actually get that one, but you could bet on stuff like that. Now, let's take a look. All right, so I would like for you, let's see what it is if it is just 18 over 38. What do we get right here? 18 over 38? Divide that out for me. 47 what? Okay, which would give me about a 47.3%. Percent chance. So now, if I just do one spin of the wheel, I want it to be red. What's my chances to be red? 47%. Okay. But now the chance of it happening again, because it is going to be 47%, but now you have 47% of 47%. That's why it's like that, and that's why we multiply. Yeah, and it's gonna keep getting smaller and smaller because it's a 47% chance of what I had the first time, right? Does that make a little bit more sense now? Yes.
So, say like that, multiply it.
Almost heard you the first time. Okay, so odds are different. Odds are different. We're going to talk about odds a little bit later. But remember, odds are the probability of the event divided by the probability of the event not happening. These are percent chances. It's not probability, that's a percent, which is slightly different, okay? I don't want you to use the long vocabulary on this one. But I know what you're saying. Okay? So, if we do it again, would it get even smaller of that? It would be like 10%. So if I was to get,
But I'm saying, how would you add it?
what do you mean? Just like I did right there. So my first event was 18 over 38, right? Okay. Times the second event, which was 18 over 38. Okay, so what if there was a third event? I would put times 18 over 38. Yeah, just like that. So does that make sense, hopefully? Okay, good.
Okay, so one of them is black, one is red, right? When you multiply it, one of those black and one of those red. Okay, for the 18 over 38.
No. It says probability of red occurring 2 consecutive plays. So the first chance, you were going for what? Red. On the second chance, you're going for red. Okay.
So where's the black? Doesn't matter.
Yeah, black doesn't. Because did it ask for black? It didn't ask for black.
So you just multiply twice? So
Yes, because it said 2 consecutive, right?
So what about 4? So you just multiply 4 times.
You would do it 4 times. If it said 4 consecutive spins or 4 consecutive plays, you would do 18 over 38 times 18 over 38 times 18 over 38 times. Yeah, just like that.
That's it?
Yeah.
Okay.
Okay, good. Did you write all that down?
Yeah, I wrote all that.
Okay, good. All right, so let's take a look at example 2 now. Independent events in a family. Okay, this is Big Vinny's problem right here. Okay, it says if 2 or more events are independent, we can find the probability of them all occurring by multiplying their probabilities. The probability of a baby girl is 1 over 2, right? Yeah? So the probability of 9 girls in a row, right? Okay, so you're saying is, so the first one was a chance for a baby girl would be 1 over 2, right? times. What about the second one? It's also 1 over 2, right? Third one. Okay. Fourth one. Fifth one. Sixth one. Seventh one. Eighth one. Am I on 1, 2, 3, 4, 5, 6, 7, 8, and then ninth one? 1 over 2, right? So, now, this is what we're going to get on my percentages. So, at the very beginning, before Big Vinny had any kids, at the very beginning, the chances, so I'm like, all right, Big Vinny don't have any kids yet. But the chances of him getting 9 girls in a row, let's see, that would be 1 over, what's it, 512? So, that's crazy. It's 1 out of 512. Now, I'm going to do a little bit more math here. So, instead of writing my 1/2 over and over again, I could use a exponent. Very good. So, I could rewrite it as 1 over 2, close the parentheses, raised to the 8, right? Wait, no, 9, sorry. And we still get the 1 over 512. And do me a favor, give me the decimal on this one. 0.019. Okay, so let's look at it like this. So now, that's my decimal. So to turn the decimal into percent, I would multiply by 100 or just move it over twice. There is a 0.19% chance. So before Big Vinny starts having kids, there is a 0.19% chance that the first 9 kids are girls. So that's a very, very small chance, isn't it? Make sense? Yeah. All right, good. All right, any questions so far about this? All right. So let's take a look at the next one. Now, if the probability that South Florida will be hit by a hurricane in any single year, it's 5 out of 19. That's the probability. Probability is written as a fraction. Odds would be different. So don't do that one yet. So odds are something different. So the probability, what is the probability that South Florida will be hit by a hurricane in 3 consecutive years? All right, so what about the first year? 5 out of what? And then what is the probability of it happening again the next year? What's the probability of it happening again for a third year? Because these are independent events of each other, it is possible that I could actually have it every year. It is possible it could keep happening every year. But the chances at it, which is my percentage, Patricia, since I know you're taking down these notes, you're not working on your old homework that you owe me already, you are taking these notes. So we get 5 over 19 times 5 over 19 times 5 over 19. So if I go ahead and multiply that out, I'm going to get 125, 6 what? 85? 8. Like that? So right now it's just a fraction. It doesn't really make sense until I actually make it to a decimal and look at the percentages. Right now it's just big number over big number, right? Write the decimal for me. What's the approximate decimal? Point what? 1/8? 2? You want a 2 there? Why not? Now, if I would convert that into a percent, right, Patricia? That's going to give me what? 1 point. So there is a 1.82% chance that 3 years in a row is going to be hit by a hurricane. So let's do the math on, let's look at the first year. What's 5 over 19? As a decimal, 263, like that. So that means that it is going to be 26.3% chance. Is that a really good chance? That is a really good chance, right? That is going to happen. So what does that tell you? So for those people that are living in South Florida, okay, that mobile home park that you're living in, that mobile home is going to be very mobile. So when that hurricane hits, your mobile home is going to end up somewhere down the street. Are you writing this down? This is like good stuff right here, man. Seriously. Hurricane. Yeah. Some people. All right, so let's take a look at B then. So this is the next part. The probability of South Florida, same thing. What is the probability that South Florida will not be hit by a hurricane in the next 10 years? Say one more time. Excellent. 14 out of 19. Now, we had this word yesterday. What is the word we're looking for if it's not? That's a what? No. Vinny. I know you weren't. Did you know? I know, right? Yes, I did. Did you pay attention to it? Oh, okay. What is the word? Hey, yes. I like your hair today. It is the complement. The complement is the number I'm missing to make it add up to 100%. Or as a decimal, 1.0. So as a fraction, this is 5 out of 19, right? To be 1, it's going to be 19 out of 19. So the complement means what am I missing to add up to be 19 out of 19? So this one's going to be 14, right? So the complement, so the not, would be 14 out of, very good. So 14 out of 19, right? And that's every single year, isn't it? For how many years? 10 years. So am I going to write this 10 times? No. We could rewrite this as a, what's that thing called? Power or exponent, right? So I'm going to put in parentheses. So do not forget when you're doing this, put in parentheses and then raise to the 10. And because it is a huge number, it's only going to give you decimals. The calculator is not going to like you if you try to do a fraction.
We did.
It did?
Yeah.
It didn't like you, did you? Do you want to try and read that?
It's like quadrillion.
I like seriously, that's like 14 digits or something like that.
280
Quadrillion. You're just making stuff up, right? Anyway, so as a decimal, what are we going to get?
0.047.
So 0.047? 77? 717?
And we take the number that the calculator gave us and just right? Yeah.
Like that? Yes? Now, let's turn this into a percent so I could actually have some reference for this. So as a percent, this is going to be 4.717% chance that it will not be hit with a hurricane in the next 10 years. That's a very, very small percentage, right? So, your mobile home that you have right there in Florida, okay, you don't want to live in a trailer park in Florida. You don't. It's not a good thing. So, there's a 4% chance that, that it's not going to be hit with the hurricane. Yeah, that sucks. So, it's almost guaranteed that it's going to be hit with the hurricane, isn't it? All right. So, you guys feel pretty good about this? Any questions so far? All right, so this is what I'm going to do for you people. So, see this right here? I'm going to stop right here. I'm going to stop right here, and I want you people right now, you guys are going to finish 11.6. We're going to use the rest of this class because I assigned 11.7. But guess how many people in here finished 11.6? 0. So, you did? Oh, I checked right before class. When did you finish it? This morning? Okay, sorry. Apologize. 1. Finish 11.6. So, make sure you guys are like, share, and subscribing. You're hitting that notification button and support my channel. Buy some of Big Vinny's hair care products. Let's go.